Hi, this is John Krochmalny, and I've created this online course on psychometric charts. You'll see my contact information at the bottom of the slide. If you have any questions or comments, please feel free to contact me. For this learning session, I recommend printing out a copy of the psychometric chart. This chart is freely available as a download from numerous online sources. Also, if you want to have a scientific calculator handy, that would be good. For this learning session, the scientific calculator is an option and not necessary for this particular presentation. Willis Carrier is considered the inventor of the mechanical refrigeration process, otherwise known as the air conditioning system. Willis Carrier was also the first person who pioneered the study of air quality. His study led to the creation of this psychometric chart in 1904. Whether referring to indoor or outdoor air masses, air quality is a term that has certain measurables. Willis Carrier identified 7 properties of dry air, primarily the dry bulb temperature measured in Fahrenheit degrees, the wet bulb temperature measured in Fahrenheit degrees, relative humidity as measured as a percentage, the dew point measured in degrees Fahrenheit, enthalpy that is measured in BTUs per pound of dry air, moisture content measured in grains of moisture, and volume per pound of dry air that is measured in cubic feet. Here we see the modern psychometric chart. As stated earlier, from this chart we can plot the values of the other measures associated with air quality. Let's start with the dry bulb temperature. This value is located at the bottom of the chart. Notice that at the lower left we have an identification box stating dry bulb temperature. The dry bulb temperature increases in value on the bottom scale from left to the right. The wet bulb temperature indication box is located directly above the dry bulb temperature box. Notice that these values increase from low toward the left to high toward the right and on the curve of the instep of the chart. Enthalpy is the measurement of total heat and is measured in BTUs per pound of dry air. As indicated, these values are listed on the psychometric chart outside of the chart's instep. Notice that these values increase in value from the lower left to the upper right. Moisture in the air is a measurement of humidity. Humidity is a term applied to the measurement of how much water vapor is in the air, and it is measured in grains of moisture. These values are located on the chart's angle section. Notice that the identification box is located at the top right of the chart. The values in grains of moisture increase from bottom to top of that scale. Relative humidity, not to be confused with humidity, is the ratio of how much water vapor is in the air mass compared to how much water vapor it can hold. These measurements are identified as a percentage. The relative humidity percentage is located in the center of the psychometric chart as a curved line. Notice that the lower curved line represents the relative humidity, and curved lines closer to the chart's instep measure higher relative humidity percentages. The psychometric chart has been created to measure the air quality of an air mass. Realize that any air mass will expand and contract upon temperature change, and therefore affect its volume. Notice the diagonal lines and identified as volume in cubic feet per pound of dry air. Frequently, the measurement of air quality begins with the use of a psychrometer. This instrument measures both the dry bulb temperature and the wet bulb temperature of an air mass. The dry bulb thermometer measures the standard temperature of an air mass. The dry bulb thermometer can be compared to any thermometer that measures temperature. The wet bulb thermometer measures the heat during the evaporation of water from the dampened wick of the instrument. As this water evaporates, it lowers the temperature of the thermometer. For this reason, this temperature is referred to as the wet bulb temperature. On the psychrometric chart, the dry bulb temperature indication box is located at the lower left of the chart. The values in Fahrenheit degrees increases from left to right on the bottom scale. Locating 45 degrees dry bulb temperature on the chart is found by selecting the temperature located at the bottom of the chart. 45 degrees Fahrenheit dry bulb temperature can be plotted anywhere on the vertical lines originating at the bottom of that 45 degree scale. 75 degree Fahrenheit dry bulb temperature is found at the bottom of the scale toward the right of the chart. Notice that there is a vertical line coming from the bottom of the 75 degree Fahrenheit dry bulb temperature. 75 degree Fahrenheit dry bulb temperature can be plotted anywhere on this vertical line. In like fashion, 95 degree dry bulb temperature is found further to the bottom right of the chart. It too has a vertical line above its value, and therefore 95 degree dry bulb temperature can be plotted anywhere on this vertical line. As mentioned earlier, the wet bulb thermometer has a cotton wick covering the thermometer's sensing bulb. When this wick is saturated with water, the thermometer is exposed to the air. After spinning the wet bulb thermometer, the water evaporates from this wick, dropping the temperature of the thermometer's sensing bulb. This temperature is referred to as the wet bulb temperature and will be lower than the dry bulb temperature. The Psychrometric Chart's wet bulb temperature indicating box is located at the chart's toe top and increases to the right up the wet bulb temperature slope. 35 degree wet bulb temperature is found approximately 1/4 way up from the wet bulb temperature indicating box. Notice that there are diagonal lines starting at the 35 degree wet bulb temperature and going down to the lower right of the chart. As with the dry bulb temperature, the 35 degree wet bulb temperature can be plotted anywhere on this diagonal line. Plotting 75 degree wet bulb temperature, we find that the value is approximately 3/4 up the wet bulb temperature slope, with its diagonal lines sloping down toward the right. 73 degree wet bulb temperature can be plotted anywhere on this diagonal line. In measuring air quality, the psychrometer is frequently used and results applied to the psychrometric chart. The psychrometer measures only the dry and the wet bulb temperature of the air mass. By plotting the dry bulb temperature on its vertical scale and the wet bulb temperature on its diagonal scale, we can determine the other 5 values of air quality from the point of intersection. Remember, with the psychrometric chart, we can plot 7 measurements of air quality: dry bulb temperature in degrees Fahrenheit, wet bulb temperature in degrees Fahrenheit, moisture in grains, this is also called humidity, enthalpy or total heat of 1 pound of air in BTUs, relative humidity as a percentage, the volume of 1 pound of dry air in cubic feet, and also the dew point in Fahrenheit degrees. Using a sling psychrometer, we measure an air mass's condition as having 65 degree Fahrenheit dry bulb temperature and 55 degree Fahrenheit wet bulb temperature. With these 2 values, we can plot on the psychrometric chart the intersection point, and from there determine the other values of that air mass's quality. We'll start with our dry bulb temperature, 65 degree Fahrenheit. Locate 65 degree Fahrenheit on the dry bulb scale located at the bottom of the chart. Remember that the dry bulb temperature is plotted anywhere on this vertical line. Next, we'll plot 55 degree Fahrenheit wet bulb temperature. When we find 55 degree Fahrenheit wet bulb temperature on a chart's instep, we see a diagonal line traveling to the lower right. We can plot 55° Fahrenheit wet bulb temperature anywhere on this diagonal line. At the point where these two lines intersect will be the origin point of determining the air quality values. Where these two lines intersect, draw a dot for the reference point. From this point of intersection, we find a horizontal line. Following this horizontal line to the right of the chart, we can see a value of 50. This 50 refers to the grains of moisture that is in this particular air mass. From this point of intersection, we find a diagonal line traveling to the top left of the chart. This line actually points to the amount of enthalpy this particular air mass has, approximately 23 BTUs per pound of dry air. From this point of intersection, we can also find a curved line indicating the percentage of relative humidity. Although it is not directly on one of the lines, we can estimate what its relative humidity would be. In this particular air mass, we can expect an approximate 53% relative humidity. From this point of intersection, we find a diagonal line in the approximate center of the graph. This line provides the actual volume of the air mass. Although the point of intersection is not laying on top of this line, we can estimate the air mass's volume. In this example, we see this air mass as having a volume of 13.4 cubic feet. The dew point is a temperature where the air mass is saturated with moisture and cannot hold any more moisture under that temperature. Under this temperature, dew forms on objects due to condensation. An air mass at dew point may also exhibit a foggy condition limiting environmental sighting of objects. Temperature recorded below the dew point will result in rain, sleet, and snow conditions. The dew point is found by locating the horizontal line at the point of intersection. Following this line to the left, stopping at the instep, temperature is going to be the indicator of the dew point. In this example, the dew point of this air mass is identified as approximately 47 degrees Fahrenheit. Here's a chance to apply what you've learned about the psychrometric chart. We will start with two measurements: dry bulb temperature 68 degrees Fahrenheit and relative humidity at 40%. From these two measured values, plot out the point of intersection, and from this point determine the other values of air quality of the air mass. You may want to stop this video at this point while you log these values. When you're finished, continue playing this video and compare your logged values with our results. With a sample air measuring 68 degrees Fahrenheit dry bulb temperature and 40% relative humidity, we find the point of intersection. From this point, we see that the air mass has 40.5 grains of moisture or 40.5 grains humidity. With a sample air measuring 68 degrees Fahrenheit dry bulb temperature and 40% relative humidity, we find the wet bulb temperature when we locate the diagonal line traveling to the top left. Notice that the endpoint of this diagonal line is 54.1 wet bulb temperature. With the sample air measuring 68 degrees Fahrenheit dry bulb temperature and 40% relative humidity, we find the enthalpy measurement by continually following the diagonal line toward the enthalpy scale. In this sample, we see the enthalpy, or total heat of that air mass, for 1 pound is going to be at 22.75 BTUs for every pound of that dry air mass. Remember, any air mass will expand and contract with temperature. Heated air will expand and take up a greater volume of space. Cool air will contract and take up less space. At the point of intersection, this air mass's volume is identified as 13.49 cubic feet. If there's a drop in this air mass's temperature, the point where the dew will start to form will occur at 42.5 degrees Fahrenheit. If the temperature drops below this value, we can expect rain, snow, and or sleet based upon temperature condition. To summarize, the psychrometric chart is used to determine the quality of any air mass, indoors or out. If we know only two measures, we can determine the other measures using this chart. Thanks for taking the time to review my presentation covering the psychrometric chart. When it comes to maintaining human comfort, the psychrometric chart becomes a valuable tool to assess present comfort conditions as well as predict what impact solutions could have on that comfort. Thanks for watching.